So now we'll be solving question number 11 from previous year problems from chapter Laws of Motion, phase 1 book. Now let's read the question. A block of mass M is at rest under the action of force F against a wall as shown in the figure. This is the one. Which of the following statement is incorrect? First of all, whenever you see this kind of question, the key part is incorrect. The incorrect option is the correct option. Always keep in mind, because our mind is synchronized to find the right answer. So many students, when they're solving these kind of questions where we have to check the incorrect, they go for correct and they mark them. Always keep in mind, it's the incorrect we have to check in this case. Now, this question will be involving a little bit of rotational dynamics as well. Since it's IIT question, so it's expected. So this question came in 2005. So mix of the concept will be there. So let me make the diagram. Little bigger diagram. This is the block. It will be having some mass given here, and the force is applied. So how it is happening? The force is applied at the central point. This force, the action of this force will be passing to the center of mass. Now one more force will be acting, which will be mg, and by definition, mg is acting at the center. You cannot shift that. Now, because of mg, this body have a tendency to go down. To prevent that motion, friction will be acting in upward direction. Since this body is not moving, friction will be static in nature. But friction will be acting always parallel to the surface. And for a time being, let's just keep the normal reaction now. We'll talk about the normal reaction. First, let's talk about these things. So, if I check the option, because we have to check the incorrect one. If we check the option, first option is F is equals to mg, meaning friction force is equals to mg, where F is a friction force. Obviously, if this body is at rest, the friction may be static in nature, and friction may be exactly equals to the downward force, the force which is trying to move it, because this body is not moving. So in this case, friction may be equals to mg. So this option A is right option. Since this is right option, it is wrong, because we have to look for wrong option. Now let's check the second option. This force is equals to normal direction. Obviously, again, the thing is, this is a driving force. This force is trying to push this block left. So to prevent that motion, normal will be acting in the right direction. If the normal is more than F, body will move, which is not possible. Normal is less, body will move. Again, not possible. So normal will be exactly equals to F. So this option is also right option. Since it is right, it is wrong. Now the third option, F will not produce torque. So they're talking about torque now. And they're talking about torque about the center of mass. Always keep in mind, if examiner is not talking about the location of torque, meaning about what, if they're not talking about the point about which torque needs to be calculated, take the center of mass. As you can see, this force in the diagram, if you extend the force, the extension of the force will be passing through the center of mass. The force is non-zero, but the movement of this force about the center of mass will be zero. So this force will not be causing any torque. Answer C is F will not produce torque, right? Because it is not causing any torque. So since this is right, this is wrong. As you can check, only one option is available, and that has to be right one. But let's talk about why it is. The fourth option is N will not produce the torque. So this is a wrong statement because this is right. Because we have to look for the incorrect statement. So this is the incorrect statement. So this statement is saying N will not produce torque. The thing is, if you can recall, whenever we used to apply the torque, we generally used to apply at the center. Generally. Thumb rule is apply the normal direction, passing through the middle. So generally, when we don't think about much, this is how we used to apply the normal reaction. If I'm applying the normal reaction this way, the normal reaction will also pass through the center. That its torque should also be zero, but it is not. It is not. So what is happening? So see, this body is equilibrium. This body is in equilibrium. And equilibrium means acceleration is zero. And angular acceleration also zero. For rigid bodies, if it is a point mass, we just look for the acceleration 0 because they don't have the dimension. But when the dimensions have to be taken into account, then equilibrium means A0 and alpha is 0. So if this body is in equilibrium, then about every axis angular acceleration will be 0. And the equation is tau is I alpha. If you are making alpha 0, it means torque also has to be 0. Meaning in this case, net force has to be 0 as well as net torque also has to be 0. So if I talk about the torque, because this body is not rotating. If I calculate the torque about center of mass, there are 4 forces: mg, F, friction, and normal, which right now are not so. So about the center of mass, torque due to mg is 0. About the center of mass, torque due to force, 0. But about the center of mass, torque due to friction is non-zero. If I talk about torque due to this friction, it's non-zero about the center of mass, and the value is friction multiplied with this distance. So out of the 3 forces, I'm getting the non-zero torque, but the net torque has to be 0. It means whatever torque I'm going to get from the normal, it cannot be 0 because if the torque to normal is also 0, then the net torque will be non-zero. To make the net torque 0, the torque due to normal should be exactly equals to torque due to friction and opposite in direction to torque due to friction. So the friction about the center of mass is having clockwise torque, then the normal direction should have anti-clockwise torque. So in this particular case, what will happen when you're applying these kind of cases, these kind of questions, the normal direction which was supposed to pass through the center will not pass through the center, it will shift. It will shift, in this case, it will shift downward. By distance x, if let's say this distance is a, there will be distance x downward. And the torque due to friction, which is Fs into A, magnitude wise will be equals to torque due to normal, which is into x. As you can see, the normal direction is not passing through the center. So normal direction will have non-zero torque. And option 4 is saying N will not produce torque, but N is producing the torque. So option D is wrong option. And we have to calculate get the wrong option. So option D is the correct option. In this question, we have seen how the normal will shift to balance the torque so that the system should remain in equilibrium. Normal reaction can shift from this end till this end to maintain the equilibrium. Okay. So I hope you understand this concept. It's a pretty nice concept. Thank you.